First, I will create a construction element measuring 100 mm by 100 mm and, for example, 1 meter long. In this case, I will use a pre-made panel and only set the different dimensions. Now, to create a tenon as a dowel, simply select all the faces on which you want to place the tenon as a dowel while holding down the left control button. You can then release the control button and press the dedicated button for the tenon as a dowel. A tenon as a dowel is a specific type of connection in which the tenon is inserted into mortises on both sides. The default size of the tenon is determined by the face size with offset around of 1/4 of the object's thickness. Its total length is the same as the object's thickness, but it is halfway hidden within the object. Therefore, in this case, the total length of the element is increased by its thickness. By default, tenons are not included in the cut list, but if you want to include them as well, you just need to change the BOM attribute to true for such a tenon. To cut the mortises for all tenons, simply select the objects you want to cut the mortises from and click the Cut Tenon Dowels button. This tool will automatically find all tenons with the tenon attribute set to yes and embedded in the selected object and perform a Boolean cut on that object. After cutting all the tenons, the cut list will still be correct, and in this case, you can also remove tenons you don't want to have listed at the cut list using the BOM attribute. The previous version of the tenon was non-parametric. This means that any changes required deleting all the tenons and recreating them. This process is quite quick, so this isn't a problem. Non-parametric modeling is much faster because it doesn't require recalculating the entire model for every minor change, and doesn't cause errors when elements are deleted. However, you can also create a parametric version of the tenon as a dowel. In this case, the face selection method is the same as in the previous example. You also need to select all the faces while holding down the left control button. However, in this case, the first selected face will be the tenon template for all the others. After selecting all the faces, select the Joint Tenon Dowel P tool. This creates tenon clones with references to the container with pattern. In this case, the lower tenon is a clone of the entire container in which the upper tenon is placed. This approach ensures that any changes to the container's contents are immediately reflected in all clones. To create a mortise in the parametric way as in the previous example, select the object from which you want to cut all the tenons. However, in this case you have to select the parametric cut tool, cut tenon dowels P. This will allow to the mortises to follow the change in the container's tenon pattern. As you can see in this case, after changing the tenon size, the mortise was also automatically resized without any user additional action. You can also change the container's content and add new tenons by copying, and new mortises will be created for the new tenons. This type of modeling is much slower because it requires recalculating the entire model, but in some cases it can be much more efficient. The same applies to deleting elements from the container. In this case, the mortise is also automatically deleted without any additional user action. However, it should be remembered that parametric modeling using part cut is not easy, certainly not for beginner users, because the project structure is quite complicated and you need to constantly check for excessive container nesting and errors. In this case, the tenons are an additional element inserted into the mortises on both sides. Therefore, the main structure can be made with a flat touch faces because all the tenons are inside without modifying the dimensions of the individual element. This is an advantage of this type of connection. In this particular case, I will first add the tenons for the horizontal elements, and then cut all the mortises in the vertical elements. However, to do this, I will first hide the vertical elements using the spacebar. Then I will add the tenons using the Joint Tenon Dowel P tool. Next, simply I select the vertical elements and cut the tenons using the Cut Tenon Dowels P tool. As you can see, this is a very quick way to add typical carpentry joints. However, it's important to remember that in a more complex structure where there may be over 100 such elements, each additional parametric change to such a model will be much slower and requires a very powerful computer. Finally, I will cut out the mortises in the horizontal elements, as this type of tenon also are inside in the horizontal elements. As you can see, the container structure has become much more complex in this case, but it is still possible to make changes to the size or number of tenons. In this case, after copying the tenon pattern and transferring it to the container with the main tenon pattern, we get an immediate update of all connections. Tenons can also be created using cutouts. First, I create a sample construction element, and then, as with the tenon as a dowel, I select all the faces on which I want to cut the tenon. But in this case, I use the Joint Tenon Cut tool. This tool creates a part design object with a cut tenon using a sketch as cut tenon pattern, which in this case is a parametric model based on the first selected face. However, as you can see in this case, the tenon is part of the element and changes the dimensions of the entire element. The created tenon has the same dimensions as with the tenon as a dowel, but in this case it is not hidden inside the element but merely cut from the element. Unfortunately, this must be kept in mind when designing the main structure with the overlap to take into account the tenon that will be cut later or cutting such tenons at once. Of course, in the cut list, the dimension of the element is the same as in the case of tenon as dowel, but in this case, the tenon is automatically included as part of the whole element that will be cut. To avoid creating a construction element from scratch again, I will first create a copy of the part design object with the cut tenon taking its dimensions and automatically creating a construction element in the selected coordinate axes. Now I can show you how to cut tenons in the new elements, but using the tenon pattern from the previous element. In this case, before selecting the faces to create the tenons, you should select the sketch that will be the pattern for the tenons while holding down the left control key. Then use the same joint tenon cut tool again. This tool will automatically recognize the first selected element as the pattern for the tenons and will not create a new pattern again. This allows you to easily create parametric model where all connections are described using a single sketch. Now simply changing the shape of the connection pattern in the sketch will change the shape of all the tenons. However, as with parametric modeling, it is important to remember that each change to the sketch involves recalculating the entire model, which can be time-consuming and very heavy for the computer for very complex structures. Therefore, carefully consider whether you need parametric modeling in each case. To create a double dowel imitating two domino dowels, I will convert the original tenon pattern to construction lines and draw two rounded dowel shapes. Of course, you can draw anything here and all connections will be updated with new pattern. As you can see, drawing such simple shapes takes much longer than usual and results from recalculating the entire model, which is a very inefficient way of modeling. Of course, the cut list will provide the dimensions of the elements needed to cut the tenons. You can't cut a mortise for the tenon on this construction element because in this case the tenon is part of the element. To show the mortise cut, I will create a new construction element by copying the previous one directly onto the face around the tenon. Sometimes this quick panel creation tool doesn't work as expected, so this is a typical magic panel. However, in this case, the new panel was created correctly. Cutting the mortise is a bit more complicated than in the previous examples. You must first select the face on which the mortise is to be cut. Then press the spacebar on your keyboard, which will hide the element and give you access to the tenon. Then, while holding the left control key on your keyboard, you must also select the face of the tenon to be cut. You can see in the element tree on the left that all the necessary elements are selected, even if the element is not visible, and then simply use the Joint Mortise Cut tool. After the mortise is cut correctly, the element will reappear automatically. Thanks to this complex selection, you can control the mortise cutting process and decide which tenons to skip during cutting. Since this is also a parametric tool based on the sketch, the cutout pattern is created based on the first selected tenon face and is located in a separate container. Of course, the patterns for the tenon and mortise are different, so they cannot be combined into a single sketch. However, it is very easy to create a parametric relationship between both sketches using spreadsheet or varset, and obtaining a fully parametric model where the shape of the tenon follows its cutout. In this case, however, the directory structure is much simpler and allows for the construction of much more complex models. In this case, you can also continue adding new mortises to an existing sketch. Simply select the sketch with the current mortise pattern to cut, then the face to cut, hide the object, and then all the tenon faces. This is quite complicated, but after a few attempts it goes very quickly. Unfortunately, such mortise doesn't track element movement. However, this can be achieved by adding a rule that links the sketch position to the element position. It's best to place both connection patterns in a separate container, which will provide a clear object tree for the parametric model. First, I will create 2 sample panels and move them so they don't hide the coordinate axes center, and so I can create the joint pattern at the coordinate axes center. Next, I simply create a sketch and a sample pattern for the tenon. In this case, there is no need to create a sketch for the mortise. Furthermore, the sketch doesn't need to be perfectly positioned at the coordinate system center because its position will be determined based on the edges anyway. Furthermore, the sketch doesn't need to be fully constrained. In this case, the dimensions are typical for a standard 5 mm by 30 mm domino dowel. Now I simply use this joint pattern using the magicJoints tool. First, I load the sketch as the joint pattern. Then I add the face for which the position will be determined and the tenon. Then I specify the face for which the mortise will be created. This is an optional step, but if you're creating both the tenon and the mortise with a single click, it is necessary. Now I simply set the position from which the joints will be created. A depth of 15 mm is correct in this case because it is half the length of the entire domino dowel, leaving a margin for the 18 mm board. When creating connections, you can also enable transparent view, allowing you to see at a glance where the connection has been created. With the magicJoints tool, you can use a sketch created directly on the face where the joints are to be created. This allows you to directly reference the object's edges through external geometry when creating the joint pattern. However, it's important to remember that the joint pattern is intended to create a tenon, not a mortise. Therefore, any borders are not recommended. For minor complications, it's better to remove them or ensure they don't create a cutout. Of course, you can also add joints later and choose whether to create only a tenon or a mortise on a given face. The magicJoints tool allows you to use any sketch as a joint pattern. This allows you to also use a sketch from a tool like Joint Tenon Cut to create this type of mortise anywhere. This approach allows you to create any joint somewhat faster than drawing each joint individually. I personally use screws and chipboards, so it has little in common with traditional carpentry, but the cabinets I make are therefore portable and very easy to create in real life. The joints are not perfectly handled yet in Woodworking Workbench, but maybe someday will be. So, let me know in the comments what type of joint you use. I might make a faster version of this type of joint. Thanks for watching. Have fun with carpentry joints.